Hey guys, this is Mr. Wistar, and in this lesson we're going to talk about static methods and variables. And I want to start off by saying that even though both of these concepts have the word static in them, we really should start to think about them as being pretty different from each other. They do share something in common in that each one of them is going to operate radically differently from the normal version of methods and variables that we're already familiar with. But beyond that, the use of the word static is almost a coincidence. But we are going to look at the same basic concepts for each one of these new ideas. We're going to look at what each one is, why it can be helpful, and the actual syntax for getting them to work. So let's start with static methods. What's a static method? Well, it is a method that you can call by just using the name of a class. You don't have to create an object, and you don't call it using the name of an object. These are methods that kind of exist outside of any one particular object. And you're pretty familiar with static methods already, even though you might not have known it at the time. You've been using them a lot in these two classes. For example, any method that you call from the math class is a static method because you have to say math dot whatever the name of the method is. There's a bunch of methods in the swing classes that are static methods. And of course the sort of granddaddy of them all, the method you've been using since day one, the main method, is a static method. And your book talks about why this is, and it kind of makes sense if you think about it. The main method gets called when your program first starts running, and so you couldn't possibly call it from an individual object because there aren't any objects created at that point. You have to create those objects inside of the main method, and so that's why main has to be a static method. So why would you want to use static methods? Well, typically static methods are good for when you have a section of your program, some process that you know you're going to need to run multiple times, but that doesn't really depend on the data that's stored in any one particular class. Java is a fully object-oriented language, which means every method has to be in some class. And so static methods were created as a way to kind of collect together all of these utility methods that don't actually depend on class data in order to work. And that's an important concept to understand. You can't touch class variables or even other class methods from inside of a static method. It really has to be totally self-contained. You can have parameters and you can have return values, but you can't touch other parts of a class. And if you do, you'll get a compile error, like a lot of you do when you try to do that inside of your main method. The way to make a method static is to just put static after the word public, just like you're used to seeing when you write your definition of the word main. So public static name of method. Okay, let's move on to static variables. Again, kind of turning the page, let's think about this in a different way. A static variable, the easiest way to think about a static variable is it's a shared variable. Most of the time when we create class variables, each object of that class has its own set of variables, but a static variable is shared among every single object of that class. They all have one copy of that variable and they all use the same copy. So there really is just only one copy of that variable that every single object of that class is going to use. Why is that useful? Well, the use cases are uncommon, but when they do happen, they're so obvious that you think, oh wow, it's good that I have static variables because I don't know how I would have possibly done this without them. For example, if you need to keep track of how many objects of a certain type you have, you'd have to use, well, it would be easiest to use a static variable. That way each of the objects can update the counter that they all share together, and you can just output that. Another very common use of the static keyword with variables is when you're using constants, which are those final variables that we create to give a name to our magic numbers. And the reason why you can use static for that makes sense, again, if you think about it. A constant variable is never going to change, which means everybody's going to use the same value for it, So you might as well save some memory space and only create one copy of that constant variable. That's why most of the time when you see a final variable, you also see that it's static. Just makes things a little bit more convenient from a design standpoint. Syntax for that is pretty much the same as the syntax for static methods. You just put the word static after the word private or public, and then you just go ahead with creating your counter variable. If you need to assign an initial value to your static variable, you need to do that on the same line when you create it. You can't do it inside of, say, a constructor, because each object of that class is going to call that constructor. And so if you were to assign a value to your static variable, then the variable would get reset every time you create a new object. So you have to assign it a value on the line here. So if we were going to do that here, we would say private static int our counter gets 0 or whatever. That's really important. Otherwise, you can use it just like any other class variable. You can access it from any class method, and you can modify it just like it's any other kind of variable in your class. Let's see a couple examples of that. So if we go to JGrasp, here's an example. If we take a look at this class of a static variable, which we're going to use to keep track of this sum quantity over multiple objects of the same class. Here's an example of a static method, and this method takes a string and reverses it. Again, that's a method that only depends on the value of the parameter, so it seems like a prime candidate for becoming a static method. And if you look in here, all we use is our parameter, and so we can get away with doing that in a class variable. Here's a method that is going to use our static variable. We're going to update our class variable, and we're also going to update our static variable, and then print out the value of both of those. So here's an example of doing that. We created two separate objects, and we called our doStuff method. So if we were to compile and run this method, notice what happens. We end up with both times that we call doStuff, my sum is equal to 7 because each object keeps its own copy of my sum, but our sum is equal to 14 in the second time we call doStuff, because they're both touching the same class variable. Let's see another example of how we're going to use that static method. If we wanted to call our reverse method, again, we wouldn't say test1.reverse because it's a static method, so we would instead say static demo.reverse, just like you would say math.square-root. So we call that, we run it, and oh, just kidding. That has a return value. We should probably put it in a print statement. And we should probably spell things correctly. Alright, and there it is. So this is one of these lessons where admittedly it's hard for me to just tell you you're going to run out there and use these two concepts all the time. But when you come across them, it's important that you understand them. You see static methods all the time. Now it's time that you know how to write your own static method when the situation arises in your programming. And you should know how to use static variables, because there's going to come times when you really wish that you could have a variable that got shared by multiple objects of the same class, and the only way to do that is with a static variable. Alright, you're all set.